Hello and welcome to another orbital mechanics video. I'm still going through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition, and I'm up to problem 2.29. And problem 2.29 is a bit more interesting than the last ones. We have an elliptical orbit and we're given the radius of 2 points on this orbit. We're given a point here which is 1,000 kilometers, and that is at 40 degrees, and we're given another one which is 2,000 kilometers, and that one is at 150 degrees. We're not given any other information. So to solve this, we have, the question wants us to get the eccentricity, the perigee, altitude, and the semimajor axis. Now, I've just made a mistake. That 1,000 is the altitude, and that 2,000 is the altitude. So we need to add on our Earth radius, which you'll see in the MATLAB script later. But the equation that we're going to use to solve this is R equals A upon 1 minus E squared over 1 plus E cos theta. Now, the reason we're going to use this is because we can equate the two scenarios. We can say R1 equals A 1 minus E squared over 1 plus E cos 40, calling this R1 and this R2, and we can say R2 equals A upon 1 minus E squared over 1 plus E cos 150. Now we can equate these by simply making these two values the same, and to do that we will create a ratio which is R2 over R1. So and we'll multiply this side by that to make these two values the same. So we'll end up with R2 over R1 equals R2 there over R1 upon 1 minus A squared over 1 plus E cos 40. So we have R2 equals this and R2 equals that, and so we can equate them. So we'll say that equals A upon 1 minus E squared over 1 plus E cos 150, and we can cancel the A and this as well, and cancel that out, and we're just left with the R2 over R1 equals 1 over that and that over that. So we can rearrange that, so we can have R2 over R1. Don't know why I started doing capital R2 R1, but you get the idea. On 1 plus E cos 150 equals 1 plus E cos 40, and then we can simply rearrange this in terms of E. So we'll do R2 over R1 minus 1 equals E cos 40 minus R2 over 1 R1 E cos 150. And then we'll take out E cos 40 minus R2 over R1 cos 150, and then we can do R2 over R1 minus 1 all over cos 40 minus R2 over R1 cos 150 equals E. And if you work that out, you should get E equal to 0.0775. All right, so if you put the E back into this equation, For R2, you'll get out A, and then if you use A and theta of 0, you'll get your perigee altitude. Just adjust for the radius of the Earth to get your final answer. And that's that. Yeah, I'm not going to do the rest of it. Just you should be able to do that by following other videos. If you think I've made a mistake, or if you have any questions, leave them in the comments below. And thank you very much. Goodbye.